All right, this week we are going to be looking at related rates. And you'll find that one of the best things that you can do on your AP free response questions related to related rates is have a strategy, an approach to solving related rates problems. You'll have videos on this for both weeks 10 and 11, and your homework problems for related rates will be during week 11. This week I'm going to focus on teaching you the problem-solving strategy, and next week I'll have 2 more videos with examples of how to use these strategies to solve related rates problems. Which leads me to an exam tip for this week. You absolutely must have a systematical approach to solving word problems. You can't just throw work on the page and hope that the person grading your test can follow it. Your AP graders, or AP readers as College Board calls them, will have a systematic approach to grading. You, in turn, will need a systematic approach to all free response word problems. As long as you have a system for showing your work and clearly stating your answer, you're sure to do just fine on the free response. So this week I am going to present a problem-solving strategy for all your related rates problems. If you take this approach to all of your related rates problems, you'll find that you do wonderful on these types of questions when the AP exam comes. I can promise you that organization in your work does lead to more points on the AP exam, and that is our goal at the end of the day. With that being said, let's go ahead and dive into our problem strategy for our related rates problems. Step 1, if you're not given a picture, you need to draw a picture. You need to have a clearly labeled picture. We are not asking that you be an artist. My stick figures are absolutely awful, but make sure that you draw a picture that relates all of the variables and constants in your problem. You will want to make sure to name all of the variables and constants in your problem. Always use t for time, and assume all variables are differentiable functions of t. Now the problem will give you numerical information. You're going to rewrite that down. Do this in terms of the variables that you have chosen. Then you're going to rewrite down what you are asked to find. Clearly state the rate that you are searching for your solution. Make sure that this is expressed as a derivative. Then you're going to write down an equation that relates the variables. At times, you may need to do some algebraic manipulation to combine a few equations to get your desired equation that you're going to differentiate. Once you've done this, you're going to differentiate with respect to t. This process is implicit differentiation, which we are learning in week 10. You will apply that process to your equation and express the rate in terms of the rates and variables whose values you know. And that's the process of solving for your related rate. Once you have your desired rate isolated, you're going to evaluate and plug in the values that you already know. Now we're going to go ahead and take a moment to see this problem-solving strategy in action by walking through an example together. So with that being said, let's jump in to our first related rates problem. All right, in this example, we have a hot air balloon rising straight up from a level field that is tracked by a rangefinder 500 feet from the liftoff point. At the moment the rangefinder's elevation is pi over 4, the angle is increasing at a rate of 0.14 radians per minute. We want to know how fast is the balloon rising at that exact moment. When we're looking for something at that exact moment, that's an instantaneous rate of change, which is our key, our clue, to finding that we're going to need to find a derivative or a related rate to solve this problem. So my first step is to draw a picture. I am going to draw a very ugly balloon that is lifted off from the ground. I'm finishing our triangle. It's at some angle between the ground and the rangefinder. We know the rangefinder is 500 feet from liftoff point, and we know that the balloon is some height in the air. We know that that angle is changing at 0.14 radians per minute. We're going to call that angle theta, and theta is pi over 4 radians. Now we have a clearly labeled picture and all of our variables and constants. We know that we want to find how fast it is rising, which is dy dt. And we want to know that at the exact moment when our theta is pi over 4 radians. Now we need to write down the numerical information that we already know. As we have almost forgot to put that rangefinder in there. Make sure we understand that that point, that corner of the triangle, is where our rangefinder is. Now we're going to write down our numerical information. d theta dt is our 0.14 radians per minute. And that's us expressing that rate of change as a quantity. And we know that our theta equals pi over 4. We do also know that the rangefinder is 500 feet, as we've already clearly labeled on the picture. Now we are going to write down what we are asked to find. We want dy dt when theta equals pi over 4. That is what we are looking for. Now we need to go ahead and write an equation that relates these variables. For those of us who have taken trigonometry before, we do see that we have a right triangle. And we know our adjacent value, and we want to know our opposite value. Opposite over adjacent, this means we want to use our tangent function. So y over 500 equals tangent theta, or y equals 500 tangent theta. This equation right here is the equation that we are going to implicitly differentiate with respect to t, which gives us dy dt equals 500 secant squared theta d theta dt. Now, we know theta and we know d theta dt. We can evaluate this by plugging in these values. Then we will be able to find our rate. So dy dt equals 500 times secant theta squared, which is square root of 2 squared, times our d theta dt, which is 0.14. We punch this into our calculator, and out comes 140. What does that 140 represent? The balloon is rising at a rate of 140. And then what's our units? Meters per second, or meters per minute. That should say meters per minute. When theta equals pi over 4. Please make sure that when you finish each of these problems, your final answer should be a complete sentence. Now that you have the systematic approach, I do require that all of your homework use these 6 steps. You need to clearly label each step. Step 1, draw a picture and name the variables and constants. Step 2, write down the numerical information. Step 3, write down what you are asked to find. Step 4, write down an equation. Step 5, differentiate. Step 6, evaluate. all homework problems must include these components. So please look forward to more videos like these next week. Have a great week.